All right, Algebra 1, this is Module 2 DBA question examples. In these first questions, we're gonna, there's a relation that's been graphed. Determine if the relation is a function. So what I'm gonna do here is I'm going to create a vertical line, and we are going to do the vertical line test. Actually, let me see if I can make a straight line here and make it nice and long. There we go. All right, so what I can do is I can grab that vertical line, and all through here, it only touches the graph in one place at a time. But then starting right here, it touches in two places at a time. We can see, for instance, that it touches here and there. So that vertical line test, because this one does not pass the vertical line test, this is not a function. And the reason it isn't a function is because it does not pass the vertical line test. So here we'll make another vertical line for this side. Oops. Make it nice. There we go. And as I grab that and move it along, it's touching in just one place everywhere, just one place at a time. So this does pass the vertical line test. So this is a function. Passes the vertical line test. These ask us to determine the domain and range. So I'm going to see if I can demonstrate one way to think about the domain and range here. And I've never really done it like this, but I'm just noticing it might be nice. Notice that this right here is, the line is x equals -5. And then here, oops, the line is x equals +5. And so that means that our domain goes from negative, well, I think there are a couple ways to do this. We're going to do it like this. -5 is less than or equal to x, and it's less than or equal to because it's there on that point -5, and that's less than or equal to +5. So our domain goes from x is -5 up to x is +5, and that's one way to write it. You can also write it like this, it's going to be a square bracket, -5 to +5. The square bracket means that it can equal those values as well. And I think that in the curriculum, they're doing it this way. If we look at the range now, the range is looking at the y values. The domain looks at the x values. The range looks at the y values. So the range, the x values, the smallest x value that's possible is this point right here. And so, I might as well try to make it a nice straight line like I did before. So that's the range. We're talking about the y values. So the minimum value is -2, and it can equal it, and it's y because it's the range are y values. And then the largest y value is up here at y is +6. So it's also equal to +6. So that one would look like this, from -2 to +6. Okay. Now on this next one, for those of you here with me in the Zoom, questions on that one? All right, the domain here for this one is nice. I like this because you can see that the furthest point to the left is this point right here, and it's an open circle, which means that the x value of -6 is not part of the relationship. but everything greater than negative 6 is. So if we're thinking about a line here, I'm going to put a dotted line here to kind of represent that negative 6 doesn't count. So negative 6 is less than x. Notice it's not equal to because this is an open circle. If it were a closed circle, it would be equal to negative 6. And then notice that it just goes on forever in this right-hand direction. So that means that x is less than infinity. And we don't say less than or equal to infinity because you can never actually equal infinity. Infinity is just a number that goes on and on. Okay? It's not a number, but anyway. I digress. The range here, the smallest y value that's possible, so the smallest y value possible, is this point right here. So notice that that is a possible y value, so I'm going to do a solid line there because it can equal that. That's negative 2 is less than or equal to y. And again, although this isn't going up very fast, it is going up, so it's less than infinity. It'll continue to go up forever. Okay, and I didn't put the other way to write these. It's going to be a negative 6, this time with a parentheses because it doesn't equal it. So negative 6 up to infinity, also with parentheses, not the square brackets. And then for the range, it's going to be a square brackets because it can equal negative 2 and it goes up to infinity. So that's the domain and range for those two. Those things can be kind of tricky, especially that second one there. Evaluate each function for the given value. So this is read as f of x is equal to 3x minus 5. The input is x. And when we have a 0 here, what it's saying is change the input to 0. So f of 0 is equal to 3 times 0 minus 5. So you can see that this x right here is replaced by 0 because this tells us to make the input 0. Now 3 times 0 is 0 minus 5. 0 minus 5 is negative 5. So what this tells us is that we have this function where when the input is 0, the output is negative 5. And we can see that this negative 5 comes from right there, and that this 0 comes from right there. So we get the input, and we get the output. And it's a point. So we can find infinitely many points in that function. All right, similarly here. So our input here is negative 6, so we have f of negative 6 is equal to, and I'm going to put these in parentheses, this negative 6 in parentheses when I plug it into this x, because I have to square the whole thing. If I do it like this, this is actually saying, first you're going to square the 6, which will be 36, and then you're going to make it negative. So you'd get negative 36. But when you have the parentheses there, what it's saying is you're squaring negative 6, which is positive 36. All right. And there's what we have. So again, negative 6 squared, that's 36. And then it's going to be plus 10 times negative 6 is negative 60. And you could have just written minus 60 here. That would have been fine. Doesn't matter either way. Now, 36 plus a negative 60, that's going to give us a negative 24 plus 22, and that will equal negative 2. So again, we have the input of negative 6 and the output of negative 2. The input of negative 6 and the output of negative 2. All right. All right, that's page 1. Let's look at page 2. Find the slope of each line. All right, so when I look at this, I'm going to look in between these 2 points. You can pick any 2 points, but since they give me those, I figure I might as well. The delta x, that's the change in x values. We're going to the right 2 units. The delta y, that's the change in y values. We're going up 4. So our delta y over delta x, because that's slope, delta y over delta x, that's going to be 4 over 2, which is 2. So here our slope is 2. And in this one, this is a line that's written in y equals mx plus b form. The slope is the m, so here our slope is 3/4. That's our solution to that one. When an equation is written in slope-intercept form, it's pretty easy to see the slope and the intercept. Sketch the graph of each line. All right, so here I'm going to start with my y-intercept is the point 0, 3. So I'm going to put a point right there at 0, 3. And I'll just highlight it with a little purple, pink, whatever color that is. I don't know. And then now my slope, whoops, that is not what I wanted to do. My slope is negative 3/4. Remembering that it's delta y over delta x, I'm going to rewrite that as a negative 3 over 4. And that says to go down 3 and to the right 4. So down 3 and to the right 4 is going to put a point right there. And so here's what I'm going to do. I'm going to come in here so that we can see that slope triangle. So delta y equals negative 3, delta x equals positive 4. Now I'm going to show you something that's pretty nice to do here. You can change this to 3 over negative 4 because those two fractions are equivalent. They equal each other. And this says to go up 3 and to the left 4. Up 3 and to the left 4. And so there will be a point right there. And so I can put in a slope triangle for that one. Going from the same point, the same original point. So here the delta y is, delta x, delta x equals negative 4 because the delta x is negative 4. And the delta y is positive 3 because the delta y is positive 3. So that's the way that we do that kind of a graph. And I'm going to go ahead, I'm going to connect those. I'm not sure if my straight line will work very well. Let's see. Oh, it worked pretty well. I'll take that. All right. Here we have, let me get the same colors. All right. We have our y-intercept and our slope. So our y-intercept is the point 0, 4 right there. And our slope is 2. But with a slope of 2, we should see that that equals 2 over 1. This says to go up 2 to the right 1. So up 2 to the right 1, we'll put a point right there because that is our slope. And so let me put in a little slope triangle. So my delta y is 2 and my delta x equals 1. Now, again, I can look at this slope as negative 2 over negative 1 because these are all equal. So that means I can go down 2, and to the left 1, down 2 to the left 1. So right there. And then I can continue to follow that down 2 to the left 1 pattern. to make all these also on there. And so I can, let's use a different color here. I can see that it's down to and to the left one. So delta y equals -2, delta x equals -1. Looks just like that. So that's this one here, down 2 to left 1. And this one here is up 2 to the right 1. And I can connect all those up. Close enough. I have the points in there, so that's good. There we go. So that is our graphing. Write the slope-intercept form of the equation of each line given the slope and y-intercept. So again, in slope-intercept form, that's just y equals mx plus b, where our y-intercept here is that's the intercept, and the slope is our m. So our slope, our intercept, our intercept. All right, so on that first one, it's going to be y equals -1/5 x plus 3. Here is our slope, -1/5. Here's our y-intercept, +3. And that's it. Now, I could have written this slope as -1/5. That's kind of a traditional way of writing it. I could have written it as, 1/-5. That would be an unusual way of writing it, but really out front or up in the numerator or down in the denominator, the negative, any of those are okay. Here we have y equals 1/2 x minus 4. So our slope is the +1/2, and our y-intercept is the -4. Now you may ask, where was this positive here? Well, if we had y equals 1/2 x plus a -4, that would be correct, but adding a negative is kind of weird. We usually just say subtract. That's how that works out. We're getting to be a pretty long video here. Thanks for sticking with me. Here we're writing the slope-intercept form of the equation of the line. So I'm going to put a couple points in here. And so here's one point. Here's another point. And if we look at that slope triangle, we see that the delta y equals +1. The delta x equals to the right 5. And our y-intercept is this point right there. So our equation is y equals delta y over delta x, 1/5 x, and then, let's see, -4. Because our y-intercept is the point, I could just write it here as the point 0, -4. So that's where this comes from, right there. Here, mark a couple points on here. Let's see where there's one right there and right here. And so this is my y-intercept, and that is the point 0, -3. And I'm going to put in a slope triangle. And it looks like I'm going down 1, 2, 3, 4, 5, 6. So that means my delta y equals -6. And to the right, 1, 2, 3, 4, 5. Did I say y? That should be my delta x. Sorry, delta x equals 5. So my equation is y equals -6/5 x minus 3. And that is the C-level problems for Module 2 DBA. Hope you find that useful. Come on in and ask questions during class or during office hours. All right, thank you.